So again, here we're going to find the period and the amplitude, then choose an appropriate viewing window to display two periods. Same type of problem. So in this case, we're going to look at the general form for tangent. So I'll write that down, and then we'll go on from there. I'll say all the pieces, and then we'll continue on. So for the tangent general form, we have everything being the same except for the period, because the period of the normal tangent function is just pi. So what happens? So A is the amplitude. However, tangent, remember, hopefully you remember, tangent looks like this, and there's asymptotes. So the A isn't really like how far it goes up, but it's how much it's stretched compared to the original tangent function. So normal tangent, this is not super important for this example, but it is important anyway. Tangent of what, pi over 4, I think that's 1, right? So if A was 3, then instead of going for regular tangent to pi over 4, instead of going up to 1, we would stretch this. If this was a 3, then this point, instead of being 1, would be a 3. I paused it and forgot because someone knocked at the door. So instead of going at pi over 4 going up to 1, if this was a 3, then at pi over 4 it would go all the way up to 3. So it would stretch it vertically. Anyway, that's enough of that. The most important difference is this pi over b part. Normally it was 2 pi over b. In this case it's pi over b because tangent has a normal period of pi. Okay, so we'll do the same exact thing that we did before. We're going to change this so that it looks like this form. The amplitude, we can just say right away, amp, that's going to be 4, just based on what it is. That means it's going to be stretched 4 times as high. So when you plug in a pi over 4, or the equivalent of that, then it would stretch upwards. But this is all shifted around, so it's a little bit different. But we don't care about that right now. So that's the amplitude. And then the period, well, I have to change this. So I'm going to write it in green. Y equals 4 tangent. And then I'm going to factor out this 2. Remember, because I don't have a coefficient there. So I'm going to factor it out. Use a bracket. 2. So 2 times minus pi, and it has to be over 4. Because if I multiply this back in, I would get 2x, and the 2, if I multiplied it back in there, it would cancel. This would become a 2 again. So that's how you do that. That's force factoring. And I can close that, plus 3. So really, this 2 is this pi over b. In fact, I do the same exact thing, except for now I'm using pi over b equals 2. So solve for b, or I can just switch them. That's what you would do. Multiply both sides by b, divide both sides by 2. You get pi over 2. So there you have it. So the period is pi over 2, and the appropriate viewing window to display 2 periods would just be from negative pi over 2 to pi over 2. And that is all for tangent. Same idea. It's just getting it into this form. This form is actually useful to remember. It's for graphing, especially if we're like doing integrals and stuff. You might want to be able to graph this. We don't get really crazy trig functions, but there you have it.